So this is another circle theorem, and it's called the alternate segment theorem. And we looked at this yesterday on my iMaths, but this is just to formalize it. This is the 5th of December. Okay, so I will show you what this one looks like. So we've got our circle, of course.
Oh, it's moving by itself.
Yeah. Okay, let's try this one more time.
You know, maybe we need to download that firmware.
Okay, so there is our circle. And this one says that if we have got a triangle within a circle, no, let me just do that again. Okay, this is actually better. Okay. So we've got a triangle that looks like this. And we have got a, what is this line called if it goes, if it touches the circle at one point, what's that line called?
If it touches, it's diameter, right? No, chord.
No, not a chord.
Chord's inside the...
Begins, you should know this. It begins with a T, yeah.
I Triceratops.
Be sensible, please. This is recording.
Oh.
T,
No. Tangent.
tangent, okay? So it's called a tangent, okay? Now if you've got a tangent meeting the corner of a triangle on a circle, then that tells us that this angle here, we call X.
Oh, I didn't like this one.
Is the same as this one up here.
I'm pretty sure that means that the right one. Wait. No, I remember this one. All of them have to equal up to 180.
No. This angle has to be the same as this one. Okay.
Okay. Oh, we're doing that one.
These two angles are the same.
Okay, never mind.
And that also tells us that this angle
It's the same as that one.
is the same as, yeah, this one down here. Okay, now the way I go about remembering this is if you've got I think of that as being the sun, okay? Now this is how I remember it, and it seems to work for me. I think of that line, the tangent line, as being the horizon, okay? And I think of, you know the way if you ever see photographs of sailboats,
Yeah.
kind of silhouetted against the sun. I think of this as the sail of a boat. Okay, so imagine this is a little boat. This is the horizon. This is the sun going, you know, it's about to go down over the horizon, and this is a massive sail, you know, of a sailboat. Okay, and so that kind of helps me remember that picture. Okay, but it tells us that this angle, this one, is the same as this one. Okay. And also this one is the same as this one. Okay, so it's just another one that you got to remember. It is a little bit of a funny shape, but you know, however you want to try and remember it. Okay.
Yep.
So that's the alternate segment theorem.
Wait, I have a question.
Yep.
So in order to find those angles, we would first have to find out what that one is down in the bottom, right?
This one here?
Oh,
Sorry.
yeah, yeah.
This one?
Yeah, we would have to find out what that one is, right?
Yep.
Because that one plus those two would equal 180.
Yep, these all add up to 180, yep.
So then we wouldn't.
So it depends what they give you. They could give you this one first. If they give you this one and say that this one is 40.
Then we know that one's 40.
Yep. Sorry, this pen's being really annoying today. This is technology for you. So if this one is 40, then this one is 40.
Yep.
And then they may give you this one. Well, that means you could work out this one, and then you could work out this one, okay? So it enables you to be able to work out all of them, okay?
But like if that one was 60, and then that one would be 80.
Yes.
Well, but it's not really a right angle.
No, it's not right angle, okay? Now, if it is a right angle, they will put your right angles in for you, okay?
Yep.
Okay, everybody got what they need from that?
Yeah. Well,
Yep. Okay, I'll just pause this for a sec. Okay, so we'll do one more, and this one is, let me see, I'll type actually, see how this works. The tangent to a circle meeting the radius. So again, this was one of the ones that we looked at yesterday as well on my maths, just to kind of formalize it. Now this one is slightly different because we're talking about, this is different to the last one, okay? So there's my center point. Okay, the line I've just drawn is the radius. And if I've got a tangent, okay, meeting the radius, it's always going to meet it at
90 degrees.
90 degrees, okay? That is always going to be 90 degrees, okay? So, turn it off. The tangent to a circle meeting the radius will always do so at 90 degrees. You got it all down now? No. It's always going to be 90. Just to clarify, this one is different to this one in what way? Because we've got the tangent. Why isn't this 90 degrees?
you can tell it.
But no. Why? You have to
Why
be. You have to
isn't
be
it not
specific.
90 degrees?
Why is this not 90 degrees?
Because the line's not going through the middle.
Okay, good. Because this is not the radius. Okay,
Yeah.
that's the important thing. Okay, this is obviously, well, it doesn't look like 90 degrees, but it's definitely not, because this line or this line is not the radius. It's only 90 degrees when
And the line's going to be the radius.
when the line is the radius, okay, meeting the tangent, okay? So just bear that in mind, okay? It's a really common mistake that people make. Right, so this is what you're going to have a go at today, okay? Circle theorems, code breaker. Yes. Calculate the size of each angle. Link it to the answers in the table above to reveal why the archaeologist was upset about their career, okay?
Can I
Because it was bone dry.
This is still recording. Yes, Damon. All right, now, just to kind of clarify, let's have just a quick look at some of these.
Can we, while we're doing these, if you like, for Again, can we pull up my IMAX, the lesson?
Yeah, of course you can. Or you can ask, or you can look back in your notes. It's a mixture of everything we've kind of done so far. The only one that we haven't really looked at is this. Oh no, we have looked at this. Because we've got a tangent. The tangent is meeting what line? So this angle here is?
90 degrees.
This angle is?
90.
Okay, we've got a four-sided shape. What do the angles in a four-sided shape have to add up to?
180. Wait, no.
No, it's 180 multiplied by 2.
Which is? 360, okay. Good. This is the first one that we did today. These are the ones that we looked at last week. For this one, this line is, AC is what?
That's a diameter.
That's the diameter. What is this angle going to be?
So that angle is going to be 6.
If I've got the, yeah, it's going to be 90. Okay, good. If you've got a triangle with one of the sides being the diameter, then the side on the edge opposite is going to be 90 degrees, okay? So have a go at that. I'll give you it out, and let's see how we can